back in 2018, IBM was the first to introduce the concept of confidential computing. When did you guys actually realize that data in use has huge potential in terms of cybersecurity threats?
You're right. We introduced in 2018 in cloud, but IBM as a whole, we have been working on it for over a decade. This is probably the fourth generation now what we have with confidential computing. And the first time we introduced into cloud as part of our service, probably in 2015 when we introduced blockchain services. So IBM blockchain, obviously for blockchain, crypto processing and security was at most important. So we leveraged our mainframe systems, our Z systems, and in which confidential computing was introduced way back, right? And then we realized as we built our blockchain service and delivering and customers consuming it, it had all the security characteristics in it, right? Including data in use, data at rest, the best of encryption with highest level control of encryption keys and all of that built in, but it was serving as a blockchain service, like as a SaaS. Then we found the need and in regulated industries that clients were looking for similar technologies as they were building cloud applications. So we could think of it as we had a packaged application, but then we realized the a la carte capabilities can actually be made available to customers to consume. So we took that and made that available as a service in 2018 as part of some of our HyperProtect services.
So if you compare 2018 to the market for confidential computing right now, how much has it grown? Do you feel like it's going to be a mainstay in cybersecurity in the future?
It will become a mainstay in cybersecurity, one of the key aspects. So one of the reasons customers start to look at this, as you look at the progression of enterprise transformation, digital transformation, and also cloud adoption, what we call chapter 2 of cloud, right? So when it comes to that, that's only like 15, when we really talk to large enterprises, banks, regulated industries, maybe 15% of the apps which handle public internal data have moved to cloud. The rest of the real estate of 80% of the applications and data have not moved. And one of the primary drivers is around regulations and risk, right? Compliance and risk. About who can access the data, where is the data, and especially in a shared responsibility model, as much as cloud providers like IBM share the responsibility of managing the accountability and the requirement lands on the institution itself, like a bank. So from that aspect, security is definitely up the ante in terms of the level of protection needed for sensitive data. So when you apply that lens, more and more the technologies are becoming ubiquitous. So I would say in kind of the hype cycle, it's probably the early, because the awareness of what it means, what it could do, even the industry view of confidential computing, right, is limited in data in use. But the way we are approaching it is more than just data in use. It's using that capability. What are all the capabilities we can provide, from confidential databases to confidential servers to confidential keys, et cetera, et cetera.
So Nataraj, if you have to point out the top 3 tangible benefits for the enterprises in confidential computing, what would it be? Of course, one is obviously security.
I mean, of course, it's grounded on security. It's about protecting data in every form, and especially while it's processing, of course. It enables new markets and new use cases. So what we have seen working with customers, there are customers like Metaco and Ledgermatic and others who deal with digital assets. In the new world, when you look at cryptocurrencies and cold wallets, the importance of security is kind of grounded in that. So as these new fintechs are coming up, leveraging this capability, it opens up new opportunities that was not there before. So from a tangible perspective, it opens up new opportunities. Third, while it provides security as a technology, like you said, as a first benefit, the other way to think about it, I would say, is from a zero trust model, you really don't need to trust anybody, right? You don't need to trust IBM because it's about hardware rooted trust and technology. So from that perspective, it changes the responsibility model in a way that customers can completely control it. Therefore, it enables the kind of transformation that they can actually do, a journey to cloud that they can actually happen. So from that digital transformation perspective, it's much more of a business transformation with agility, right? It's about accelerating to cloud, which they've been kind of slowing down, but it enables that. So I would say, while security is the anchor, it moves security technology further. It enables new business opportunities, use cases, markets like digital asset custody, and as a differentiator for those fintech-like companies, as well as the third is accelerating digital transformation.
So in theory, of course, the confidential computing will see these legacy systems, sensitive data move to the cloud. But when you actually talk to the CIOs and the chief information security officers, how skeptical are they when you tell them that you don't have to worry about your sensitive data because confidential computing could potentially keep it safe?
Look, there is, from a risk perspective, even as a security guy all my career, I'll always be paranoid, right? So it's about balancing risk. So from that angle, confidential computing is one of the key technologies. When you look at it holistically, the level of controls needed to implement security, be it from network or identity, privileged access, data security, or as well known from the last many years as vulnerability management, right? So when you look at that whole thing, moving to the cloud is more than just confidential computing. So what we have done and what we announced, what we have as IBM Cloud for Financial Services is a great example, because the focus of controls framework, working with banks, not just, hey, it's an IBM point of view, it's working with Bank of America and other banks that we have announced with. Thinking from an industry perspective of the type of controls needed, the level of monitoring and transparency needed, because there's control. Confidential computing is a key part of the control of whether you control your data, etc. The other side is visibility, transparency. So IBM, from our transparency perspective, how we do the depth of security controls, also the level of evidence that we provide to these banks as part of FS Cloud, or Financial Services Cloud, is important. So CIOs or CISOs look at it holistically, not just a technology perspective. It's ultimately about risk. So what's the risk? How do you mitigate the risk? And then how do you meet those compliance regulations and requirements in a continuous manner with ever-changing requirements across the globe? So I would say definitely it's an enabler, but it's not like a silver bullet.
How does it work in conjunction with artificial intelligence and machine learning? And are there any issues that could arise considering that the AI training or the inference of algorithms in the AI could be trade secrets?
It's very interesting that you asked that. We are seeing some emerging use cases. Let's call them secure multi-party analytics, right? So an example you can imagine is in the US and probably in other countries as well, there's organized crime in retail, right? So theft happening in retail stores, and then there's a pattern. So when they look at the theft happening in a particular store and a particular chain of stores, they also realize it's a similar kind of crime that's happening in other retailers. But sharing that data on what is lost, etc., is like may not be trade secret, but nonetheless sensitive data from their perspective. But as they want to collaborate across the retailers to solve this problem, they are using their machine learning and AI to detect patterns. For this to detect patterns, now not only you have local machine training that you need to feed in, but also sharing the data. In that context, working with some of the retailers, we have work going on with hyperprotect virtual servers and databases and crypto, in the confidential computing portfolio, where they're using this, where think of it as each of them can do their own local machine learning. And then as the data moves into this enclave of processing, it is going to feed across these data sets, identify patterns, and feed back the patterns. In that perspective, the data is completely controlled by each retailer using their key. So one retailer's data is not exposed to another retailer. So from an AI machine learning perspective, it is enabling such use cases where data can be shared in much more of a secure manner than just sending unencrypted data over. We have seen another use case, an interesting use case is also in healthcare. We worked with in MIT labs, something called GeneTank, where they were doing genome processing, DNA analysis to detect on one side diseases. Pharma companies were interested, insurance companies are interested to understand the patterns, and end users are trying to figure out how their DNA can be analyzed and what you can look at it. So if you look at multiple parties who are interested in the data, obviously the DNA data and the sensitivity around it must never be disclosed nor be correlated to the person. But the outcome of the analytics, machine learning, AI will lend itself to the different perspectives of be it insurance providers or pharma or individuals.